Discover's AES battery is specifically designed for off-grid, microgrid, and diesel abatement or remote power applications.
Yep.
It's more robustly built than most of the residential lithium batteries. It's LFP cells, it's a 48 volt battery bank. This particular model is a 6.65 kilowatt hour or near 7 kilowatt battery. And again, designed specifically for off-grid applications to pair with hybrid inverter chargers. Yeah, virtually, I mean, to any practical limit that you would want to expand a residential off-grid or a small microgrid system to, you can simply parallel these batteries. Code compliance in keeping that in mind. There are several different methodologies you can do. We are capable of doing battery-to-battery paralleling,
yep.
Electrically speaking, or running these to a common bus bar, a single point of common contact.
Okay.
In terms of the actual battery itself, there's two parts to the connection. There's the electrical component of it, which is your DC cable runs.
Yep.
And then there is something else to consider that's unique to this battery as opposed to most, and that's the communications networking paralleling of the battery.
Good. Okay, so tell me a bit about the communication sides. I noticed there's some ports here on the top.
Yeah, so this battery can be used in, I guess in Australian terms, a managed or an unmanaged mode. Okay, unmanaged mode, it just operates as a lead acid battery replacement. Simply the terminal connections are reporting voltage and the like.
Okay, so no special comms that'll work with any inverter that works with a 48 or
total
24 volt version?
Totally capable of retrofit any traditional or existing lead acid system.
Yep.
No comms, any vintage of inverter charger, any make model of inverter charger, no problem at all. Simple setup, just configure it for bulk absorption and float as we direct in the manual, and you'll have a battery that's going to operate, to 2 and 3 times the capacity of a lead acid battery and recharge 4 to 5 times quicker.
So you can also, using this AE bus, use it with a managed system with a compatible inverter?
Exactly. So we have 2 CAN channels on this battery built into the board. AE bus is Discover's proprietary CAN protocol,
yep.
And we use this bus, again, just RJ45 CAN network connection, to aggregate or to gang multiple batteries together. That has them basically report as a single battery block.
Yep.
That's kind of important because with CAN you have some traffic limitations. Rather than having each battery incrementally adding that traffic onto the network, what we're doing is aggregating the batteries, so when we do connect to an external network, we're connecting it as one node or one block.
Okay, so you really can scale these a lot in that regard.
Exactly. As a specific example, we actually have Schneider Electric ZANBus built into the board here.
Right, so very Schneider friendly straight out of the box.
Yes, exactly, and that kind of comes with some of the lineage of the personnel that we have and how we're co-located to them in the Vancouver, Canada area.
Yep.
To give you a good example of how that works, so we would gang several batteries of these together,
yep.
Have them report, and then we would simply connect or designate one of those batteries to be the ZANBus node. You plug in the ZANBus network to this on a terminated network connector, and essentially as soon as you did that, you would see our Discover AES battery appear on the system control panel or COM box. We would push and auto-populate all of the settings and configurations for that inverter system. So in this case, it's a 130 amp hour battery. If we had 2 of them, it would represent a 260 amp hour battery automatically. 130 amp hour battery. If we had 2 of them, it would represent a 260 amp hour battery automatically.
I remember this happening to me, and I thought I had to program it, and I couldn't change the settings.
No.
And I think I emailed you about this, and you go, no, we tell you the setting. We tell the inverter what settings.
Yes, exactly. And for, I guess 2 things. First of all, for the average installer, it takes away time, scrolling through all those menus and things, and it also takes away the human error in terms of just missing a step in the setup. Furthermore, homeowners are prone to tinker, and at least for the critical settings that we want for this, you have an inability to overwrite those fields. So the ones that are critical to us and what we want to see from a charger's perspective are you cannot change. The batteries are telling the inverter what it wants to see and now, what that parameter should be.
You've got a few boxes here. What's this one here? Let's get a little closer look at this.
Perfect.
Tell me about this.
So this is our link device, and again, we talked specifically about an example here where you have ZANBus. The link device essentially acts as our other channel. There we go. Our other device channel. that allows you to export to other networks that aren't resident on the BMS. So in this particular case, we can do the same level of integration with Victron's platform, Sunny Islands. We can look at Studer Innotech, at this point in time, all the major CAN-based communication protocol power electronics manufacturers are integrated. You'd simply, again, you disconnect this, you'd populate it with an edge card that's power electronics specific, and then basically connect that network just as we suggested here with ZANBus on our battery, and it would allow you to do the same level of integration. Again, pushing settings and configuration, device configuration for you, having all the data aggregated over their third party or their collective system monitoring for this device. And the thing that is very unique to this, rather than just broadcasting SOC and status, we actually, when we're talking about a closed loop or a managed battery system, we're doing more than most batteries do. We actually become the master, and those power electronics become the CCCV slave to what our battery wants to see. So throughout this is primarily a feature of recharging, right? Lithium is so much faster than lead already, but the holy grail for off-grid systems is fast recharge. So what we can do when we're able to dynamically recharge is we take the information that's already on the BMS, cell voltage, cell pack temperature, and cell spread in terms of any kind of deviation in cell voltage spread. If the battery conditions are good, we can actually change and put a very dynamic or a very aggressive charge profile in, a higher voltage, say. Normally, let's say if it was a static or unmanaged battery, we would put in a setting like 54 for bulk and absorption. In this particular case, when it's dynamically controlled and the battery is driving, we can get up into 57s in that nature as well, barring conditions are met for it, and have an aggressive charge that typically reduces recharge time by about 25% compared to an unmanaged battery, lithium battery.
I notice also you've got a little display on the front, so this is also a simple display.
It also acts as an on-site SOC meter. So and it's aggregating the however many batteries you have. So it's not a device-dependent thing. You don't need one-to-one with your batteries. This would take whatever size battery bank and represent the whole as a block combined.